Number one, the country's debt is growing at an annual rate of 3.5%. What percent rate is it growing at per month? What is it growing at per month? Now, you might be tempted to just divide that by 12, but that's not how percents work. When we did compounding monthly, we would divide it by 12. But it's not compounding monthly. It's still compounding at the same rate. I just want to know what's the equivalent monthly percent. So, well, if I'm growing at 3.5%, well, that's 0.035 as a decimal, because I'm growing, it's 1 plus 0.35 to the t, where t is years. So we have 1.035 to the t, and I have some principal amount that I don't know what it is. Right now it's about $20 trillion, which is sad. So I want to know what's the monthly rate of change. What is it growing at per month? Now, if we just think for a minute, should it be higher or smaller than 3.5%? Well, it should be smaller than 3.5%, because if it was bigger than 3.5%, it'd be growing quicker over a year. So to make it smaller, I'm going to raise this number to the 1/12th power, because there's 12 months in a year. This quantity will give me the monthly percent rate of change. So when I go to my calculator and type in 1.035 to the 1/12th, now there's another way I could have typed this in. I could have taken the 12th root. So if you go to math number 5, I could have taken the 12th root, because remember, power over root, that still is the most important thing you need to know, is power over root. These two numbers should be the same, and they are. So, what is it growing at a monthly rate? It appears to be growing at a monthly rate. It's p times 1.00287, let's say, to the m, where m equals months. So if I want to know how much it grew by after 18 months, I'd plug in an 18 to here. So it's just changing the units. But because I want the monthly rate, it has to shrink. It has to get smaller, so I'm going to take the 1/12th power. If this was the monthly rate and I wanted the yearly rate, I'd raise it to the 12th power to make it bigger. But because I wanted to make it smaller, I'd raise it to the 1/12th power. So what percent is that? Well, what percent is that? Is 0.287%. 0.287% is the percent rate of change. Number 2, the population of a town is decreasing by 4%. Decreasing by a percent is exponential, and we're decaying because it's decreasing every 5 years, and started with 12,500 residents. Create a model and use the model to predict the number of people in the town after 10 years. So let's do that first. So the population after t years, well, let's say t equals years, is I'm starting with 12,500. I'm decreasing by 4%, 1 minus 0.04 to the t, but it doesn't decrease every year, it decreases every 5 years. So I'm going to divide by 5. Well, after 10 years, p of 10 equals 1250 times 0.96 to the 10 over 5. So it makes sense that I have 0.96 here because I'm losing 4%. 100 minus 4 gives you 96, so that's why there's a 0.96 there. 10 divided by 5 is 2, so I can just do 12,500 times 0.96 to the 2. It happens twice. That 4% decay happened twice. So I'm down to 11,520 residents. What's the yearly percent decrease? Well, it's 4% every 5 years. So I'm not just going to divide, I'm going to use that power to a power rule. So I'm going to do 0.96 to the 1/5 t. These two models are equivalent because I'm just doing the power to a power rule. I'm doing 0.96 instead of t over 5. I'm going to do the 1/5 first. If I wanted to type in the 1/5, I can literally type into the 1/5, or I could take the 5th root. So what's the yearly percent of decrease? Well, the model becomes 0.99187. Let's go 0.99187 to the t. So let's do 100 minus that decimal to find the percent of change. I'm just going to do 1 minus because I have that number right here. 1 minus that decimal. I want to make that a percent, so times 100. Every year, ignore that second line, I'm losing 0.81%. 0.81%. I'm kind of working backwards. I'm giving you the function, and I want to know what's the word problem. Every year, I lose 0.81%. 0.81% is what I lose every year. After 5 years, that would give me a 4% decrease, approximately. Of course, there's some rounding going on here. But if you ever want to find the yearly percentage change, you just use a power to a power rule. A payday loan company makes loans between $100 and $1,000 available to customers. Every 14 days, customers are charged 30% interest. That's a lot. Compounding, so it builds on itself. In 2013, Remy took out a $300 payday loan. Create an exponential model for P of t, the amount she would owe after t days. So P of t, she took out $300, 30% interest, so 1 plus 0.0, 1 plus 0.30, but it doesn't happen every day. Remember, t is days. It happens every 14 days, so t over 14. So the model that I would use would be 300 times 1.30 to the t over 14. That would be my model. So if I had 100 days, I would plug in 100 for t, do 100 over 14. But it's important to understand that it compounds every 14 days. Every 14 days, I apply that 30%. Number 4, create an exponential decay model for 100 grams of strontium-90 if it has a half-life of approximately 29 years. Define all your variables. So let's say t equals years, and we'll say S of t is the amount of strontium-90 remaining. The amount of strontium, I believe, is Sr in the periodic table. Sr90 after t years. So S of t equals, I'm starting with 100 grams. It's a half-life problem, so I'm multiplying by half. T over 29, because it happens every 29 years. Create a model to highlight the yearly rate of decay. I know the decay rate after every 29 years, so I'm going to use a power to a power property to create a new model. S of t equals 100 times, I'm going to do 1/2. I'm going to raise that to the 1 over 29 to the t. That'll highlight, this here is going to tell me the yearly rate of decay. So 100, well, what's 1/2? Let me clear this all out. 1/2 to the 1 over 29. What's the 29th root of 1/2? 0.976, let's say. So this highlights the yearly rate of decay. What does it decay by each year? Well, let's do 100 minus that, or 1 minus that. 1 minus 0.976, and around there, times 100 to make it a percent. This means it decays by 2.4% each year. I lose 2.4% each year. It takes 29 years to get through half of it. So after 29 years, I lose 50%. But every year, I lose 2.4%. Number 5, if $5,000 is invested in an account that compounds interest quarterly, I know how to deal with that. Determine the annual interest rate of the account after 5 years, if after 5 years the account has that much money. Okay, So we know this is A equals P times 1 plus R over N to the NT. I know how much money I actually end up with, 5805.92 equals, the principal is 5,000, that's what I started with, 1 plus, I don't know the rate, I'm compounding quarterly, so N equals 4, to the 4 times 5. Okay, so I have 5805.92 equals 5,000 times 1 plus R over 4 to the 20. So the first thing I'm going to want to do is divide by 5,000. I want to get rid of that 5,000. Divide by 5,000. So 5805.92, don't put 2 decimal points, divided by 5,000. So I get that lovely number there, 1.161184 equals 1 plus R over 4 to the 20th power. Well, how do I get rid of a 20 power? I can take the 20th root, or I can raise it to the 1 over 20. Raising it to the 1 over 20 is taking the 20th root. So, it's easier to type in your calculator to the 1 over 20. That gets rid of the 20th power there. So, that is 1 plus R over N. That tells me that number there is 1 plus R over 4. This number is 1 plus R over 4, so I'm going to get rid of the 1. So that's the rate over 4, times 4 will give me the rate. So R is approximately 0.03, which gives me 3%. There's about a 3% rate of change. A 3% interest rate would yield me that much money.